So we finally get to the tangent and the reciprocal functions, and let's just go ahead and get right to it. We already know what the graph of the tangent function looks like. You guys did that wonderful project on the butcher paper. I will let you know on probably by Wednesday who won that. But anyway, let's go ahead and flip through these. We can just remember the tangent is the sine over the cosine, so wherever the cosine is equal to 0, that's where you're going to get your vertical asymptotes. Okay, so that's the most important thing to keep in mind, because that's what will get you at least the right x-intercepts. The x-intercepts are always right in between the asymptotes. Okay, so another thing to keep in mind. I'm really not concerned about how steep you make these. The most important thing about knowing what the tangent function looks like is that you get the asymptotes in the right place and you get the x-intercepts in the right place. And so the easiest thing to find is where the cosine is equal to 0. And when you find where the cosine is equal to 0, that makes from one vertical asymptote to the other is going to be that one period. So find the period as close as you can to the y-axis. All you have to do is draw one. Again, the x-intercepts are always smack dab in between those vertical asymptotes. And then just make sure that the tangent function goes up from left to right. It's always increasing over every period. And here, if you want to pause the video now and take a look at this information here, it's the same stuff that we did back in your Cosmic catalog. All right, so there are some transformations though that we need to be able to be aware of. If you remember that, well, I'll get to that in a second. So the two out in front, we don't have an amplitude of the tangent because the tangent goes up from the range is all real numbers. But we do have a this -1 here that we start with a tangent function. Multiplying it by 2 doesn't increase the amplitude. Again, we don't have amplitudes for anything but the sine and cosine, but it does grow faster. As you notice, the tangent curve is closer to the asymptotes sooner than it is when it's the tangent of 2x. Okay, so that's the only thing to keep in mind. Still, the limit as x approaches, oh wait, you don't know limits yet, so we'll get to that. But the graph of the tangent function still approaches the vertical asymptotes to the right. When you approach the vertical asymptote from the left, I should say, it's still going to go up to positive infinity and go down to negative infinity from the left. So it's still increasing from left to right. Keep in mind that the x-intercepts are always going to be smack dab right in between the vertical asymptotes, and the vertical asymptotes are going to occur everywhere the cosine is equal to 0. And so notice that the cosine of, let's see, where are we at here? 2 times tangent of x minus 1. Okay, so we don't have cosine is equal to 0 when x is equal to pi over 2 and so forth. And 3 pi over 2 and so forth, like I said. So there's really nothing much else to do here except take this graph here and drop it down 1 unit. Subtract 1, vertically shift down 1 unit. So if you know the basic graphs, you'll know how to graph these as well. Now here's where I said we're going to go ahead and see this a little bit later. Well, here we are. We do have a period issue here to deal with, and if you remember the sine and cosine, the period was 2 pi divided by the coefficient of the x, and it's the 2 pi divided by the w. But for the tangent, since the tangent's period is pi, then the tangent period of the transformations would just be pi over 2, or pi divided by that w. Okay, and so pi divided by the w is what I would do first. I wouldn't stretch it by 3. Did you notice there's a misspelling on this page here? Stretch. Okay. Anyway, the first thing I would do is I'd go back to that last video and remind myself, okay, I only need for sine and cosine, I need 5 key points. Well, for the tangent, you only need 3. Okay, but I guess the fourth and the fifth one would be where the vertical asymptotes are. So the first thing I would do is notice that the period of this particular function, y equals 3 tangent 2x, is pi over 2. So if the period is pi over 2, then that means that we take the pi over 2, right? So the period is pi over 2. The period was originally pi, and you just go right there near the origin, and you go, if period is pi over 2, then you go pi over 4 out to the right, and then you go pi over 4 out to the left. Okay? You're just going to squeeze it right around the x-axis, or sorry, the y-axis. And let's see, I don't really feel like I explained that really well just there. But let's start with this one. The period is normally pi. Okay, so if the period is pi, you cut pi in half, and you go out half of pi to the right and half of pi to the left. Start at 0. Plot an x-intercept. And then, well, if the period is pi over 2, then you cut pi over 2 in half, and you go out pi over 4 to the right and pi over 4 to the left. Okay? That's it. And you got to make sure, or you could do it. Here's another way you could do it. You know that the cosine of 2x is equal to 0 when x is pi over 4, because 2 times pi over 4 is pi over 2. That's where the cosine is going to equal 0, cosine of pi over 2. So if x is pi over 4, you're going to get a vertical asymptote. Well, then just either scoot forward pi over 2 radians, or, which is one period. Remember, the period is pi over 2. And so if you start at your first vertical asymptote, pi over 4, then you could back up. You could back up pi over 2 radians and draw another vertical asymptote, and then put your x-intercept right in between. We know that the tangent always moves up from left to right. I could care less about you guys putting this dot right here or the dot right there. Most important parts of the tangent function and the cotangent would be the vertical asymptotes and the x-intercepts. Just draw 2 vertical asymptotes and draw an x-intercept in between, and you will be done. And then just draw the curve, increasing from left to right. Okay. Now the cotangent function, you've got to pay attention here. The cotangent function, why, you should be able to answer this question. Why are the vertical asymptotes at the y-axis, and then pi, and then 2 pi, negative pi? Why are these values, why are these lines the vertical asymptotes? You got to ask yourself that. Well, the answer, somebody's coming in my room. Okay, time out. So the answer to that is because the sine, the cotangent is the cosine over the sine, and wherever the sine is equal to 0 is where we're going to have vertical asymptotes for the cotangent function. And that's why. So you got to pay attention. This is the one function that students make the most mistakes on. They just assume that the vertical asymptotes are in the same place for the cotangent and the tangent. That's a big assumption. That's wrong. Okay, now the other thing about the cotangent is the cotangent function is decreasing over every period. Okay, so the same thing. Find your first vertical asymptote. You look at the period of the cotangent, same as the tangent, is pi, so just go over pi to the right or pi to the left. I care less. Draw your next vertical asymptote, and then your x-intercept is always right in between. Okay, so let's take a look at a transformation. Oh, so I'm not going to, I guess we don't have any transformations of the cotangent function, but if you know how to do the transformations of the tangent, then you'll know the cotangent as well. So the cosecant, I want to point this out. The cosecant, the easy thing about this one is we know that it's a reciprocal of the secant. Sorry. Let me back up. I look here. Cosecant of x, we know that's the reciprocal of the sine. Okay? So the sine function is what you're going to graph first. I want you to understand that the cosecant function is not the one in black right here. Okay? The cosecant function is, they only draw the sine function, which is what you should do as well. So if you're graphing the cosecant of x, you first graph the sine of x, and notice the cosecant and the sine, the key parts here are cosecant and the sine are the same only when the sine is equal to 1. So wherever the sine is equal to 1, since the cosecant is 1 over the sine, the cosecant also has to be 1. So wherever the sine is 1, cosecant is 1, and then it's just a U shape. It's a reciprocal, so it goes up towards the vertical asymptotes. You should also understand why the vertical asymptotes are where they are. Again, the cosecant is 1 over the sine, so it's just like the cotangent. Wherever the sine is equal to 0 is where you're going to have vertical asymptotes. So you can see it. You can see the x-intercepts. So wherever you have an x-intercept on the sine graph, you have a vertical asymptote for the cosecant. And just keep in mind, the cosecant is always going to look like this. It's always going to be just right there, big U shape right there, and upside down U right there. It touches the sine curve at the high and the low points. Okay? And if you think about it, the secant would be the same exact thing. The secant function, reciprocal of the cosine. Draw the cosine first. Okay? So you're going to get a chance to do this in class, but draw the cosine first, touch the cosine function with the secant function. Everywhere the cosine is -1 or at 1. You only need to draw one, period of the secant function as well. And again, you should know why these are vertical asymptotes. The secant is 1 over cosine, and the cosine is 0 everywhere you see the cosine equaling 0, right? So the cosine is 0 at -pi/2, pi/2, 3pi/2, and so forth. Now, I think I might have a transformation for you. So I would encourage you to take a look at this function here. The first thing you're going to do for the transformations, the easiest way to do this, guys, is just replace it. Just draw the graph of y equals 2 times the reciprocal of cosecant. Draw 2 sine x minus 1. Okay. And you start with the sine of x here. Then you have 2 times the sine of x is here. You should draw that. And then you subtract 1. You just drop it down 1 unit. Okay? And then just draw 1 period. 1 period of that sine function. And then wherever the sine function hits the high points and the low points, just draw a little U shape. Okay? Draw a little U shape. And then an upside down U shape down here at the low points for the sine. You only need to draw 2 of these. Okay. Well, I didn't realize these videos are going to take this long, so you got 45 minutes worth of videos. I would say go ahead and just watch the first 2. If you have time, watch the third one. Third one's a bit of a mess. Yeah. If I should probably redo that one, but anyway, I did that one first, and I'm feeling a lot better about these first 2. So I think you'd be good with the first 2, and then maybe just I don't know. Might not even do that last one. But yeah, you got to do the last one because you have a phase shift in that one. So any phase shifting in some of your work that maybe we'll do Tuesday, Wednesday, maybe we'll save that for Thursday, Friday. So that's what I'll do. Just do the first 2 videos and you can be done with this one.